Hello, today we're going to be talking about a case for outsourcing in the aerospace manufacturing industry. We are Group 1 and our team members are Sylvia, Lisa, Nick, Robert, and Lauren. Our team's research will provide compelling support for the use of outsourcing alternatives in the aerospace manufacturing industry. We have collectively worked very hard on this project and were able to gain important insight into the importance of in-depth research and big data. The Aerospace Industries Association concluded in a study conducted in May of 2016 that the American aerospace and defense industry is a vital component of the U.S. economy. Not only because of the role the industry plays in a national security, transportation, and technological innovation, but also because its influence spans across many sectors and every state in the United States. Designing domestically is a very labor-intensive process. The interconnected steps shown here demonstrate that the current domestic design process can place many constraints upon companies as they try to recuperate their expenditures and offset their costs elsewhere. There is an overall reduction in profit, which can also directly affect suppliers. The consolidation of suppliers power can lead to greater bargaining power and the use of an established supplier base. Due to the limitations imposed upon companies due to domestic design processes that are currently in place, we propose some needed changes that can help to improve outsourced design and manufacturing. These changes include focusing on a cost-effective workforce, maximizing a corporate budget resource use, and providing more supplier and manufacturing alternatives. Additionally, we propose that variables like labor cost, profitability, and supplier leverage can be considered in these changes. Lastly, employing effective web analytics parameters is essential to implementing successful changes to current processes. Unlike the domestic design traditional processes, the enhanced process focuses on international design to increase profits by freeing corporate budgets, meeting and enhancing corporate needs due to budget flexibility, and increasing supplier competition due to lower supplier side bargaining power. Labor cost reductions and a flexible workforce are key considerations when adopting this enhanced process.
Before utilizing data application to enhance internal operations, we were seeing rising labor and engineering costs with designs done domestically. High-cost operations can have a negative impact on an organization, resulting in limited resources that can be used to improve manufacturing outputs. In our case, this type of process put most of the bargaining power in the hands of our domestic suppliers and was reducing overall financial resources. As a result, we were running the risk of compromising quality and had no segmentation of engineering complexity. After utilizing data application, our findings proved that we'd be able to implement a new process that would lower cost operations by outsourcing internationally. With this new process, we'd be able to obtain greater profits, increase access to a larger supply base, and lean out operations. Together, this results in greater budget margins that can lead to a more optimized utilization of financial resources and design capabilities. In order to effectively implement a more internationally minded design process, we carefully analyzed various data sets to guide our effective decision making and corporate initiatives. We wanted to evaluate education levels to see their effect or correlations with our workforce tier of complexity. Several modeling techniques are useful to consider when analyzing data sets. In our case, clustering work type by engineer design and manufacturing allowed us to identify the best locations to outsource each type to. The same with correlation of labor force. Breaking it down by high labor force productivity and labor force participation allowed us to see where secondary education level scores were of greater or lesser value in each given region.
Several data sources must also be analyzed in order to proceed with corporate decisions. Sources of online data that can be sought include the company's own internal financial information, and benchmark data sets can provide important insight into the company's own operations and global variables that can affect its success. In addition, data involving financial information for multiple institutions, education sources such as education and labor boards, and available talent in the market can provide even more data that the company can use in its analysis. Moreover, performance metrics must be considered in order to provide a more specific overview regarding variables that can affect a company's operations and profit margins. For example, the velocity of product development, existing corporate profitability, organizational efficiency, and quality escapes can collectively be analyzed to provide a structured vantage point in which to analyze existing and future initiatives regarding corporate processes. It's also worth to mention that people can be significantly affected by proposed changes and the adoption of enhanced processes. Not only can customers, suppliers, and governmental entities such as the FAA be affected by these changes, but the company's employees can be impacted. Therefore, data analysis and other important consideration must be weighed before taking significant steps towards the implementation of new processes. In order to illustrate the impact of supplier costs on design processes, an experiment is provided in which two groups are compared. In this study, the control group is comprised of the average cost of U.S. suppliers, and the variables test group includes the average cost from group of randomly selected international suppliers derived from a set. Based on iterative decision-making approach, big data analytics were used to successfully select international suppliers. In addition, cost savings were effectively compared between domestic and international suppliers.
In this experiment, labor costs were analyzed in order to test the hypothesis that the control group would experience reduced labor costs by using selected international suppliers. The hypothesis was tested by segmenting work in accordance with labor force and their attributes. In the control group, labor force was aligned with specific work broken up by complexity. For example, certain types of work that required a certain level of education was paired up with countries that provided a workforce that aligned with those needs. In addition, a variable test group was limited to doing all work domestically, as the industry has been doing for quite some time. The measured outcomes are lower supplier cost from an international supply base, which enhances competition in the supplier market, resulting ultimately in higher profit being received by aerospace manufacturers. Another outcome that can be measured is reduced in engineering development expense. We expect for this to result in lower engineering costs in order to develop new programs, as well as possibly reducing the time in which it takes to develop programs, simply because this approach will free up bandwidth within the aerospace manufacturing industry. In our new process, we would encourage aerospace manufacturers, rather than to look internally to solve all of their problems, to also look externally. In our process, we have built in this check so that every time a new requirement is received, the following steps would be followed. and thus the opportunity would not be missed. Step 1 would be identify. As requirements are received, aerospace manufacturers would define those requirements and categorize them based on complexity. Step 2 would be align. This is a crucial step where all requirements would be aligned with either domestic or international providers based on key attributes and complexity. Third would be the decision point, where requirements and providers would be matched up by mutually beneficial attributes. Step 4 would be perform. Step 5 would be evaluate. And step 6 would be completion. The following references were used in the development of this presentation.